Hi there, this is a couple of projectile motion questions. So this will be examination questions, or examination start questions part 2. So you want to pause and have a go at this video, then I'll take you through the answers. So on this one, we've got a cannonball being fired at an angle of 30 degrees from the horizontal at 30 degrees at a velocity of 150 meters per second. So we're going to calculate three things. We're going to find the maximum height reached by the ball, the time of flight, and the horizontal range of the cannonball. So first of all, we need a little diagram to indicate, what's exactly happening. So we've got 30 degrees from the horizontal, and it's a 150 meters per second. And then we can start. So the maximum height reached by the ball. So the maximum height will be, suvat vertically. So I'm going to write suvat. So the displacement S is what we're going to take up as positive actually. So the displacement is S. The initial speed is the initial vertical velocity. Now the initial vertical velocity is this one. So that would be 150 times sine 30. So let's just write that in. So 150 times sine 30. Sine 30, remember, is just a half. So 150 times a half is obviously 75. The final velocity is the velocity once the ball's at its maximum height. So the vertical velocity at its maximum height would obviously be 0. The acceleration is due to gravity is acting downwards. So that's minus 9.81 meters per second squared. And then the time, we're going to find the time anyway, so we'll just leave that there. So anyway, first of all, let's find S. So we need an equation to find S. So let's use the v squared equals u squared plus 2as and rearrange to find S. So v squared minus u squared divided by 2a. So v squared minus u squared over 2a will give us the maximum height reached by the ball. So v is 0, so then we've got 150 times sine 30 squared, which is 75 squared, divided by 2 times acceleration of 19.62. So 75 squared divided by 2 times a, 19.62, gives us a maximum height of 286.697, so 287 meters will suffice. In an examination, obviously, I would advise you to use a minimum of 5 significant figures, but this isn't an examination. So 287 meters is fine, so that's the maximum height. The time of flight. So for the time of flight, we need to obviously find time, t. So we need an equation to do that. So we should use v equals u plus at. So v equals u plus at, and then rearrange to find t. So that would simply be v minus u divided by the acceleration, and that will give us the time. We want the time to the maximum height. Once we've got the time to the maximum height, if we double it, then that'll be the time of flight. So v minus u will be 0 minus 150 times sine 30, so that's minus 75. Divided by the acceleration, which is minus 9.81. So you just need to do 75 divided by 9.81, which gives us the 7.645 seconds, and then obviously times that by 2 to get the time of flight. So the time of flight in total, all right, times 2 there. Time of flight in total is 15.29 seconds, or 15.3 seconds. Okay, so hopefully you got that one right. And then what we need to do is a horizontal range of the cannonball. So we're going to do suvats again, but we're going to do it horizontally. So I'm going to take the right as positive, and then I'll talk through a few fundamentals here. So the displacement is what we're looking for, S. The initial speed horizontally will be, the component that is here. So we need 150 adjacent to the angle cos 30. So that'll be 150 times cos 30, and then the final velocity would be horizontally would be the exact same, because there's no horizontal acceleration, there's nothing slowing it down, and there's obviously nothing speeding it up, so the acceleration is 0, and the time is the amount of time that it's going horizontal for is the amount of time that it's going vertically upwards and downwards. So that's simply 15.3 seconds. So really we're using s equals ut plus half at squared, but the acceleration's 0, so the half at squared part of it just is 0, so we're simply left with displacement is speed times time. And for this type of question, this is always the case. So the horizontal range of the cannonball is simply the horizontal speed, which is 150 times cos 30, multiplied by the amount of time that it's in the air for, the 15.3 seconds. So that gives us a displacement of 1,988 meters. So if you got that, really well done. And what we can do is move on to another question. So the final question. Hopefully that went okay. Let's have a look. So you've got to pause and have a go at this one. And then when you're ready, I'll take you through the answers. So a bullet is fired from a gun and travels 250 meters per second at a target 100 meters away. And what we're going to do is calculate how far the bullet has fallen. Okay, this is an interesting one. So to calculate how far the bullet has fallen, we need to know how long it's falling for. So we can calculate the amount of time it's falling for by calculating the amount of time that the bullet is traveling horizontally. So what we can do horizontally, obviously there's no acceleration, so we can simply use displacement is velocity times time. So time would be the displacement s divided by the speed or the velocity u. So the displacement is 100 meters horizontally, divided by the speed horizontally, which is 250 meters per second. So if you do 100 divided by 250, that will give you the time of flight of 0.4 seconds, which is important to answer this question. So how far has it fallen? Well, if we know the bullet is falling for 0.4 seconds, then we can calculate how much distance that is. So let's try to solve that again. So SUVAT, but this time we're going to take down as positive. I don't know why that keeps doing that, but there we go. So S is what we're looking for, S. The initial speed vertically is 0 meters per second. It's moving horizontally but not vertically. The final speed V, we can find that as well afterwards for part 2. The acceleration is simply plus 9.81 because we're taking down as positive meters per second squared. And the time that it's falling for is the 0.4 seconds that it's moving horizontally for. So what we can do first of all is to find how far it's fallen, is to use S equals ut plus a half at squared. So the initial speed vertically is 0, so that cancels. So we're simply left with displacement is a half at squared. So 0.5 times 9.81 multiplied by 0.4 squared. So that gives us a displacement of 0.7848 meters. So 0.7848 meters. If you're given that as a final answer in a test, it would be 0.78 meters. That'd be fine. Okay, then we need to find the bullet's vertical velocity as it hits the target. So that would simply be V equals U plus AT. So down as positive again. We've got the information above. So V equals U plus AT. So the initial speed vertically is 0. So it's simply acceleration 9.81 multiplied by the 0.4 seconds. So 9.81 times 0.4 seconds will give us 3.924 meters per second vertically. Okay, so the last bit, the resultant velocity of the bullet as it hits the target. So, well, we've got two velocities now. We've got the horizontal velocity of 250 meters per second and the vertical velocity of the 3.924 meters per second. And what we need to do is find the resultant. And we can also find an angle while we're at it, because obviously velocity is a vector, it must have direction. So that's 3.924, and the top one is 250. So first of all, you can use Pythagoras to find the numerical value of the velocity. So that'd be 250 squared plus the 3.924 squared, and then square root it. So So that's just some Pythagoras. And it actually comes out at 250.03. So not much change. So numerically, there's not much difference. So it's 250, the vector, essentially. Let's find the angle out and and see what the angle is for the direction. So we've got opposite, we've got adjacent. So that'll be tan of the angle is equal to 3.924 divided by 250. So let's see what this is. So theta would be inverse tan of that value. I'll actually write this in, 3.924 divided by 250. So if you calculate that, that gives an angle of 0.89 degrees or 0.899. So 0.9 degrees from the horizontal. So hopefully that went okay. And thanks for watching. Hope you found that useful, and I'll speak to you soon.